Okay, I'm like, I don't know, day 3 of this kind of a broad project where I'm converting a notorious flux core welder from Harbor Freight, like the cheapest one, been around for ages. For the price, it's fine, but it has this one flaw. It's an AC electrical welder instead of a DC, where in this particular type of welding technology, which is called flux core, and it has an odd electrical arrangement, and I imagine that's just to keep it cheaper. So the point is, I'm taking my time. I'm doing a lot of cool modifications. I'm going to be taking it out of the case and mounting it in a weld table that I'm working on, which is kind of early stage. Lots of big plans for this. I'm going to beautify it and all this other stuff. Going to mount the welder down there. And so I'm just trying to take this cheap welder, and since I don't have the electrical components to convert it right away, I'm just kind of taking my time. I put the fan, usually the fan rests inside the case. Instead, I put some grommets back there, mounted the fan on the outside of the case to increase the airflow in here. Because a lot of reports talk about this fan, when it sits in here, it kind of obstructs think about the sides being onto, it ends up obstructing the airflow. Now, I do have much more powerful fans. I have some fume extractors that I want to put in there, but I'm just going to do like more of a simple standard upgrade. And in these standard upgrades, if you don't have the electrical components, you come in here and you do some wire management, and you change some wires, maybe put either a better quality wire, either a bigger wire, or another thing you can do to improve wiring is to shorten the wires. Long wire runs increase resistance, decreasing energy efficiency. Bad quality wires, similar, decrease electrical efficiency. So what was that? That's long runs, bad quality, and wire management can introduce interference because electricity. You have current carrying conductor and a magnetic field with relative motion between the two. So if you were to look at this under a microscope, you'd see electrons kind of swirling around it. So yeah, there's some light potential for poor quality cable, long runs, or badly managed cables to introduce some sonic inefficiencies. Probably not audible by the human ear, but you get into car audio, and then you get into DJing and large audio systems, and then you live in a car during COVID where you are building both audio system and living components for comfort. You get kind of anal about shit, and one thing I'm kind of anal about is grounds and grounding. Now, this is probably nothing, but imagine that this was connected right there. So what was going on is where this penetrates the case, you see that little hole right there? So the wire goes through the big hole. And in the little hole is a little plastic, like, set screw. Not even fucking metal. That presses into it. So if you look at it, you'll see that this damn thing, this is going to be hard to hold and show you. Let me see, maybe I can do it like this. There we go. It's like, bloop. So all in all, that's probably not even a big deal, but I can't abide that at all. Not going to abide that. So I clip it, and I'm going to kind of periodically just do some updates on the build and do some discussions, and just to kind of have a discuss things that are kind of important. So I'm kind of like stripping back this heat shrink, which wasn't even fully shrunk on. It's just kind of like really baggy and kind of loose. I like my heat shrink to be fully shrunk, but and then I noticed this. I'm like, okay, again, at the end of the day, probably not a huge deal, but that's nagging at me, because you're taking a $60, $70 entry-level welder that is historically really not a good welder. And by not a good welder, it's this thing where you have the welding gun is positive on this, and this is supposed to be DC electrode negative. It's the ideal situation where the grounding clamp becomes positive, and then this is the wire, when it hits the metal, becomes the ground. So DC electrode negative, right? With a flux core welder. It's just the ideal situation, and it has to do with some of the nuances of power ratings and the type of welding component you use. Lots of factors that go into it, right? So my mentality is, okay, if you have a turd, at least polish the turd. You know what I mean? Like do everything that you can within your power, what I call best practices, to improve it. So I'm updating I'm not going to really update most of the wires because, I don't want to go in here and try and rewrite. Well, first off, I've never even worked with a transformer, so I don't exactly know how to wire that properly. And so I'm not going to reinvent the wheel here, but I am going to address any glaring concerns as far as, well, obviously, that. Bloop. So right now, the fact that there's like this weird just exposure right there, and I have welded with this, it was sloppy, it was, it wasn't a fun process. But there's a series of a few different mods that you can do to improve the performance. Now, heating's not so much an issue, but that fan being in this little zone and being the source of the air push, it's kind of now in the path of the air. And then this goes right up against here, right? So you got to think the transformers are going to be kind of hot. Air doesn't have very far for it to move before it encounters like major obstacles. So air's not going to be flowing very well in here. And I guess, from some of the other videos I've seen where they mod this, they say, yeah, when it was sitting in here, you didn't feel any airflow. Imagine you got your walls going up. But the instant you put your fan out here, it puts the fan, first off, outside the heat chamber. So the fan is going to be more efficient, and something else producing heat next to the transformer, which is producing heat. Now they're both separated from each other. One's outside the heat chamber, and the transformer is the sole proprietor of the heat chamber now at this point. But this fan being able to now still be a fan in there, but further back, now you get the ability for this thing to pull through a smaller opening, right? If this is just all completely open, you're not going to get as much of a thrust of volume or a volumetric flow rate of air. Like imagining the whole back was off isn't going to be as powerful feeling as now like this, where there's a hole that it has to pull the air through, and then it has a little bit of time for it to move. There's less heat in here, there's less obstruction, more cooling is going to take place. It's probably a very minimal improvement, if any, but it's still, when you have best practices, that's something, that's an easy one to take care of, right? Then, usually grounds, I'm rewiring, because I mounted this on the outside, I had to, cut some new holes, I had to put rubber grommets in there that are the right size, and then as I'm starting to fish wires through the rubber grommet on the bottom, I forget to do this one, so I have to cut it a second time. I'm like, oh fuck, this is already going down down the tube. Oh, you see those white lines? So like, that's a plan. So I'm gonna just cut that line, cut that line. So these are all just long lines. And then when I cut that one, these are gonna be larger gaps. I want to increase the amount of airflow because ultimately what I think I'm gonna put there's a pretty powerful fume extractor. Remove this from the AC load of the welder, because the welder, the welding action is sending like a high electrical current usually down into a medium that's going to become a metallic weld somewhere. But this type of welder is also using the same electrical source to turn a spool and run a fan. So my thoughts are, well, why don't I just take this fan out of the equation, which is it's a very, very low power fan, but take it out of the equation and put like a fucking fume extractor out there that's running off of a different energy source and has its own power switch, so that it's stronger, moves a lot more air, takes zero power from the system, so the system now has a little bit more power. This is going to be a lot cooler, it's going to be a lot better airflow. So that's kind of like the things that I'm talking about. I'm doing like weird little, kind of like, well, I guess I would say I'm an electrical wiring snob. I do beautiful wire management, and I will not abide shitty grounds and all that shit. So I'm just kind of having fun with it. And so this was something that was interesting. And then I noticed that's interesting. So we'll see. We'll see how this turns out. You know, I'm not going to reveal all the mods, but I'm just kind of going with the flow. But one of the other major things I'm going to be doing too is, you know, I'm trying not to even have these sides on. I want to get rid of this little high edge here, this high edge here. I'm going to make a new panel that maybe this panel stays there, or I make a new panel where I can remotely access these buttons. Now this is going to be at my feet, but I want to have, you know, where I'm welding, I want to have access to these features so I can do, you know, modifications on the fly. So I'm going to be doing some things that I've never seen anyone do. And then of course I'm going to be doing all of the important mods that I've seen everyone do. And this is a super fun project, but yeah, let's just see. This is the before. How the hell am I going to not just improve this, but what path am I going to take with this wire mess? I don't know yet. We'll see.